Welcome back to the physics class, my dear students. So in the previous class, I was discussing regarding the power of a lens. So I just defined you that the power is the ability of a lens to convert or to diverge the incident beam of light. Then I even said that the SI unit for a power is diopter. And even we just discussed that the power of a lens can also be defined with the help of a tangent. So just I will define that one. So I am just going to define the power of a lens. To define the power of a lens with the help of the tangent, I am using a convex lens. So just I am going to write a convex lens here. Whereas you know that it is having a principal axis and an optic center. Now just consider a convex lens with an optic center O. Then I am going to incident a parallel beam of light which is parallel to the principal axis. I am just going to mention that as PQ as an incident ray. When it falls on the lens, so that at an height h from the optic center, so it refracts and passes through the principal focus, right? Then Q is said to be the refracted ray. My dear students, you can observe it carefully. If I just extend this incident ray PQ, the angle which was present between the refracted ray and the direction of incident ray is theta. So then, if this angle is theta according to mathematics, this angle also should be equal to theta. See, you can observe it very carefully. We have applied a mathematics over here. So I am just going to write the value of tan theta. So from the figure, what is the value of tan theta here? You know that according to mathematics, tan theta is written as opposite by adjacent. So opposite is h, adjacent is focal length. This is a convex lens with the focal length small f, whereas focal length is the distance between optic center and principal focus. So that tan theta is equal to opposite by adjacent, that is h by f. Take it as equation number 1. But my dear students, there is a definition for power of a lens. See here, while we are defining it, the power of a lens, so as we defined in the previous case, no need to use angle and all, but to define with the help of a tangent, I just want to define the power as. So that power, it is an angle, it is a tangent, it is a tangent of an angle, by which the lens converges or diverges the incident beam of light at unit distance from the optic center. Yes, you can observe it carefully. I am just going to read it out again. So it is an tangent of an angle by which a lens converges or diverges the incident beam of light at a unit distance from the optic center. It means this is a distance from the optic center and the incident ray. What is it? So it is an angle, tangent of an angle by which it is going to converge or it is going to diverge in case of concave lens. When the incident beam of light, this is the incident beam of light, incident at the unit height from the optic center. Unit height from the optic center. So this convergence power or the divergence power of a lens is simply said to be the tangent of an angle theta. So that this is by definition. So power of an angle is said to be a tangent of angle. So take it as equation number 2. Then according to equation 1 and 2, so you can equate both the things. So P becomes equal to h by f. See, as you observe that here they given it is a unit distance from the optic center. So then what happens? H becomes equal to 1. This implies that P is equal to 1 by f. So that the power is said to be the reciprocal of focal length. So we just derived that the power is equal to 1 by f just by using a mathematics and defining it with the tangent of an angle. Please be careful, dear students. The power of a convex lens is always positive and the power of a concave lens is always negative. Okay? We discussed the power of a lens. So whereas in previous class we discussed its SI unit also, then we should know the linear magnification also. So what is said to be the magnification? How to define the magnification? You know that if you place an object in front, so if you place an object, so that if you are going to observe an object with the help of a convex lens, so we are going to observe the different position of an object, so the different position of an image or different position of an object, as well as it even forms some erect images as well as it to be the real image. See, it means sometimes it forms erect and sometimes it forms virtual. So that is what I can say, erect and virtual images or real and inverted images. Lens at the sometimes convex lens forms real and inverted image, sometimes it forms virtual and erect image. So ನೆನಪಿರಲಿ erect ಬಂದಗಡ virtual ಇರುತ್ತೆ, real ಬಂದಿರೋ ಕಡೆ inverted ಇರುತ್ತೆ. So don't confuse with the things. So ಹಾಗಾದ್ರೆ convex lens ಅಂತ ಬಂದ ತಕ್ಷಣ it is not only the lens which is going to magnify, sometimes for some different position ಏನಾಗುತ್ತೆ, so the image position ಏನಾಗುತ್ತೆ magnify ಆಗುತ್ತೆ, sometimes image position diminish ಆಗುತ್ತೆ. So that we should know that what is magnification, how to define the magnification. See my dear students, magnification is represented by the symbol small m. Then how to define this magnification? Magnification is a ratio of, it is the ratio of, it is a ratio of height of the image to the height of the object, to the height of the object. Overall, even the magnification can be defined as the ratio of image distance to the object distance. Yes, these are the two different ways to define the magnification. So that the magnification in this case m can be written as hi by h0, whereas hi is the height of the image and h0 is the height of the object. In this case, the magnification is defined as v by d u. V is the object image distance and u is the object distance. This is how to define the magnification. So sometimes the size of the image is enlarged compared to that of the object. Sometimes size of the image is diminished as compared to that of the object. So that depending upon what is the size of that object, that is what the see, writing of formulas. So whereas this formula is not for your examination, it is for your competitive examination. So we can write the formula for magnification with the help of focal length and object distance. So the magnification formula which is going to relate with the focal length and the object distance can be written as m is equal to f divided by f plus u, where f is the focal length, u is the object distance. And also we can write the magnification as m is equal to f minus v divided by f, whereas v is the image distance and f is the focal length. So my dear students, this is a way how to write the different ways of formula for magnification with the help of focal length, object distance and image distance. Suppose while we are performing an experiment, if we get the magnification greater than 1, if the magnification is greater than 1, we can say that the object is enlarged, the image is enlarged, means the enlarged image has been formed. Suppose if we get that the magnification is less than 1, it indicates that the image form is said to be diminished. The image form is said to be diminished. So not only this magnification is greater than 1 and magnification is less than 1, even we can define this magnification for the virtual as well as real images. See, when we come towards a virtual, it forms always an erect image, while always forms inverted image. Dear students, while we were discussing in this way, so while I am just writing a virtual image, so virtual image indicates that it is forming an erect image. Erect means that if the object is in this way, so the image also should be in this way, right? So suppose if it is going to form a real image, so if it is a real image, it is always going to be inverted. That is what? The upside down. If the arm up is upside, we get the image in a downward direction. So whereas if the virtual image is formed, if the erect image is formed, then we can say that the magnification is positive. Magnification is positive. If we have the inverted image, the magnification becomes negative. The magnification becomes negative. Keep in your mind. So if this is useful for solving numericals. So if the image is erect, then the magnification is positive. If the image is inverted, then the magnification is negative. These are some of the key points that you should remember. So just which helps you to form, that helps you to solve some of the bits in your competitive examination, as well as which helps you to solve some of the numericals. Suppose, my dear students, if I just give a piece of a glass. So I am not going to say this is a plain mirror. I am not going to say clearly this is a convex lens. I am not going to give the clear picture this is a concave lens. Just I am going to give you a piece of glass. So I will just ask you to say, to confirm the given glass whether it is a concave or whether it is a concave or convex lens or it is a plain mirror. So how you are just going to, how you people are just going to conclude that the given piece of a glass is convex or is concave or it is a plain mirror. See, when we give a piece of lens, you can perform an experiment just by placing a candle and you can observe the image on either side of on opposite side. That is what opposite side, on the remaining side of a lens. So that if you observe that the image which is formed is magnified. So then you can say that the magnified image is formed. It indicates that the given piece of a glass is convex lens. Suppose if the image formed is diminished, then the given piece of glass is going to act as a concave lens. Suppose if the object size is not going to change, there is no change in the size of an object, then we can say that the given piece of the glass is going to act as a plain mirror. Hope you got this. If you are given conclude that whether it is a convex, concave or plane mirror by the time what you are going to observe. You can perform an experiment that you can observe. If the image formed is magnified, you can say that it is a convex lens. If the image formed is diminished, then you can say that it is a concave lens. If the image formed is not having any change in the size, or it is not having any changes in the image, then you can say that the given piece of glass is going to act as a plane mirror. This is all about how actually the lens, how actually the convex lens is going to behave, and actually the concave lens is going to behave, and how the plane mirror is going to behave. Keep in your mind, plane mirror is the one which is having always a magnification equal to 1, because the image size of object size of same, height of an image and height of the object both are same in case of plane mirror. Not only that, the object distance and the image distance both are same in case of plane mirror, so that the magnification in case of plane mirror is always equal to 1. Dear students, so even we should discuss how actually the convex lens and the concave lens is going to form images. To discuss that, so even we can write n number of ray diagrams. So let us see. Before going to that, I just want to explain you the effective focal length, the equivalent focal length of combination of lens. So derivation of expression for equivalent focal length of combination of two thin lenses. Yes, while we are combining the lens, we have the convex lens, we can do an experiment, we can just design any optical instrument with a single lens, right? Then is there any need of combining the lenses? Yes, my dear students, it is there. There is so many advantages of combining the lenses. So before going to the derivation, first let us see what is the need of combining of two lenses. And also let us define what is equivalent or effective focal length. What is equivalent focal length? Yes, let us define the equivalent focal length. My dear students, so it is a focal length of a lens which gives the same effect, which diverges as the combination of the lenses diverges. It converges as the combination of the lens converges. It has the total focal length which is equivalent, which is same of combining of two thin lenses. It means rather than just using one lens, if I use the two lenses, then it gives an image. That image is similar to that of an image formed by the equivalent lens, that is what a single lens which was placed in place of two combination of lenses. See my dear students, what is equivalent focal length, as well as before going towards the equivalent focal length, even you can simply define equivalent lens. See my dear students, equivalent lens is a lens which forms an image of an object as it was formed by the combination of two lenses. I am repeating again. Equivalent lens is a lens which forms an image of an object as it was formed by the combination of two thin lenses. It means we'll get the same kind of image that we got by combining two lenses. Equivalent lens ಅಂದ್ರೆ ಒಂದು ಸಿಂಗಲ್ ಲೆನ್ಸ್. ಸೊ ಎರಡು ಲೆನ್ಸ್ ಕಂಬೈನ್ ಮಾಡಿ ನಮಗೆ ಏನು ಎಫೆಕ್ಟ್ ಸಿಗುತ್ತೋ ಅದನ್ನ ಒಂದೇ ಲೆನ್ಸ್ ಅಂತ ತಗೊಂತೀವಿ. ಅಂತ ಒಂದು ಲೆನ್ಸ್ ನ ಈಕ್ವಿವಾಲೆಂಟ್ ಲೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ತರ ಈಕ್ವಿವಾಲೆಂಟ್ ಫೋಕಲ್ ಲೆಂತ್ ಅಂದ್ರೆ image of an object which is exactly same as that of the image formed by the combination of lenses. Not only that, equivalent focal length is the focal length of a lens which was obtained by a combination of lens. So this is about the equivalent lens and equivalent focal length. Then is there any need of combining of the lenses? Yes, my dear students. So you know that if I use a convex lens, it always forms erect and also it always, sorry dear students, I am just repeating again, it always forms, my dear students, see, I am just repeating, convex lens so convex lens always form real and inverted images. Sorry, I am repeating again, it always forms inverted and real image. Convex lens always forms real and inverted image, but only one case is that when the object is placed between the optic center and the principal focus, by the time will get erect and virtual image on the same side of the object. But rather than this case, in almost all the cases, convex lens forms you the real and inverted image. Similarly, when we come towards a concave lens is a one which is exactly going to form you the virtual and erect images. Whereas, my dear students, if we just come towards one of the single case in case of for each case in case of concave lens, so in each and every case we can observe the erect and virtual images. So this is what we can say easily, that we have a convex lens which forms real and inverted. We have a concave lens which forms an erect and virtual image. Okay, good. So sometimes we may have one of the lens which is having less power. My dear students, the less power is going to magnify a very small amount of the object. It means the image form is not that much clear. So whereas the image form is inverted, so the image form is exactly of not clearly magnified. So there may be some of the distractions which was present in the image which was formed on the screen. So to rectify all these things, we are moving towards combination of lenses, especially in case of telescope, in case of camera, in case when we come towards microscope, there all we are using combination of lenses. Even in simple microscope, even in compound microscope, even in your telescope, even in case of even camera, people are moving towards using of two different lenses. Why we are using two different lenses? When we come towards only the one single lens, that is said to be the convex lens, what it will do? It forms inverted and real image. But my dear students, if I am just placing a convex lens and I am observing far away or far object, so I am just observing that as an inverted image. But that inverted image is not enough to just get a clear information. So what I want to do that, I want to invert the inverted image. So for that reason, if I place another one convex lens, what happens finally? I can observe the erect image. So you are getting. So for that reason, I am just going towards the combination of lenses. So what are the advantages of combining of two thin lenses? Yes, students, we can combine two concave lens. Even we can combine two convex lens. Even we can combine convex and concave lens. We can combine any of the two lenses for our better explanation of the image which was formed by the combination of lenses. For our practical applications, especially in case of optical instruments, we always use the combination of lenses. Then what are the first uses? So to invert the image, to get the erect image, we use the combination of lenses. And as well as, so erect image ಆಗಬೇಕು, so inverted image formation ಆಗಿರುತ್ತೆ. ಅಂತಂದ್ರೆ ನಾವು erect ಮಾಡಲಿಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ? Combination of lenses, ಎರಡು lenses ನ ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ. ಅಷ್ಟೇ ಅಲ್ಲ, so if we use only one single lens, field of view is very less. To increase the field of view, we are using two lenses. I'm repeating again, two. Get an erect image, we are combining lenses, as well as even to increase the field of view, to increase the magnification, to get the clear image, to get the clear information on the screen, we are just using the two combination of lenses. Now, I am just going to derive the expression for equivalent focal length of convex lens. So I am just using a 2 convex lens, whereas this derivation is similar to that of the derivation that what we did for the lens maker's formula. So my dear students, here I am using 2 convex lenses, just which helps us to just avoid using of minus sign conventions. So that I am using 2 lenses here, whereas this is lens L1 and this is said to be lens L2. Both the lenses are having their own optic center O and O dash. Now I am going to consider an object O. So agar you may get a doubt, then from where we should calculate the distance, ma'am? Because you said that all the distances should be measured along the principal axis from the optic center. But here we have 2 lenses, then from which point we should measure? Exactly, my dear students, your doubt is correct. We should measure from the point of combination. So here I just placed the 2 thin convex lenses which are in contact. So even you can place the 2 lenses with some distance. Means if you place one lens here, you can place another one lens here which is separated by distance t also. I will just show you the formula in the next class because the derivation is not there for you, but we have the derivation for this, the 2 thin lenses which are in contact. So now the distance between, see I am just going to draw the dotted line here, so that the distance between the object and the point of combination of the lenses is said to be the object distance represented by U. Now from the object, the ray of light is going to incident. The ray of light is going to incident. So when a ray of light is going to incident on this, so what happens? Assume that the lens 2 is absent. Assume that the lens 2 is absent. In the absence of second lens, the first lens is going to form an image at I1 with a distance of V1. See, O is an object for lens L1 and I1 is an image for lens I1. U is the object distance for lens L1. V dash is the image distance for lens L1. Now, whereas the image which was formed by the lens L1 acts as a virtual object for lens L2. Why I am calling this as a virtual object? Because the virtual object is here, whereas I am using I1 as an object for the lens L2. It means I1 is acting as virtual object. So that now assume that the first lens is absent, so that here the ray of light is coming into the lens L2. So that after refraction through the lens L2, it forms image at I. So with the distance of V is said to be the image distance for lens L2 and I is said to be the image for the lens L2. Finally, we can say that I1 is acting as a virtual object for lens L2. Okay, dear students, with this, now let us move for the deriving of the effective focal length. So we know that the general formula. So you should write one thing where L1 is a first thin convex lens, L2 is a second thin convex lens, and whereas O is an object with an object distance U. I1 is an image formed by the lens L1 with an image distance V1, and V is an image formed by the final image formed by the lens L2 with image distance V. These are all the things that you should write first. After writing all such things, you know the formula, general formula, that is what? 1 by focal length is equal to 1 by focal length is equal to 1 by object distance plus 1 by image distance. That is what 1 by f is equal to 1 by v minus 1 by u, but I written here it as 1 by u plus 1 by u is a general formula. Right. Now let us consider the refraction through the first lens. I am just moving with refraction through first lens. Refraction through first lens. Right. Yes. What we will get now? See, for the first lens I have to write the focal length as well is object distance, and also I want to write the image distance. Yes, the focal length for the lens L1 is f1, so the focal length is positive. Why? Because it is a convex lens. Object distance is u for the first lens, and image distance is v1 for the first lens. Dear students, here you can observe that the incident ray is in this way. Now we are measuring the image distance along the direction of incident ray. Then v1 is positive, no problem. But we are measuring the object distance opposite to the direction of incident ray. Incident ray is in this direction, we are measuring it in the opposite direction. So u becomes minus, right? Then let us substitute this in the first equation. Substituting 2 in 1. I am just considering this one as 2. Substituting these values in 2. So what will happen? So 1 by f1, which is equal to 1 by image distance is 1 by v1, and plus 1 by object distance is 1 by minus u is minus 1 by u. Take it as equation number 3. So we just discussed the refraction through the lens L1. Now let us see the refraction through the lens L2. Yes. So what is the focal length? I am not going to write again. So what is the focal length? The focal length of the second lens is f2, but you should write again all these things in your notebook. But here I am not writing it. So what is the object distance? Sphere. Object is I1, so that the object distance is v1. And what is the image distance? Image distance is v. See, now let us apply the sign convention. We are measuring the distances along the direction of incident ray. So v is positive, v1 is also positive. But there is another one sign convention. Real object and real image distances are positive, and virtual object and virtual image distances are negative. I1 is a virtual object, so that the object distance becomes negative. So now let us substitute this into this one as equation number 3. Equation number 4. Substitute 4 in 1. So what you will get? See here, 1 by focal length, that is 1 by f2, which is equal to 1 by object distance plus 1 by image distance. So 1 by object image distance is v minus 1 by v1, that is 1 by object distance. So take it as equation number 5. So we have the two equations, equation 3 and equation 5. Let us add those two equations. Add equation 3 and equation 5. So what we will get? 1 by f1 plus 1 by f2 is equal to 1 by v1 minus 1 by u plus 1 by v minus 1 by v1. You can observe it carefully. 1 by v1 minus 1 by v1 cancel. Remaining is 1 by f1 plus 1 by f2 is equal to 1 by v minus 1 by u. You know that 1 by v minus 1 by u is 1 by f. So that 1 by f1 plus 1 by f2 is equal to 1 by f. So this is what the expression for the equivalent focal length of combination of two thin convex lenses which are in contact. So how to define that? The effective focal length, the reciprocal of effective focal length of a combination of two thin convex lenses is always equal to sum of reciprocal of the individual focal lengths. This is about the derivation of the focal length of combination of two thin convex lenses in contact. Suppose if I just place one convex lens and another one is said to be the concave lens, then what happens to the effective focal length? And my dear students, you should be very careful. You can even write it as a note in your notebook. Suppose if we increase the combination of lenses, it means if we focal length is going to reduce, but the power is going to increase. So that while combining combination of the lenses decreases the effective focal length, but increases the effective power, because focal length and power are inversely proportional to each other. Dear students, here I just given the 1 by f is equal to 1 by f1 plus 1 by f2 is a formula for combination of two thin convex lenses in contact. Suppose if I use one convex lens and one concave lens. If convex and concave lens are in contact, concave lens are in contact. Contact alidre ಏನಾಗುತ್ತೆ? See here, convex lens is the one with the focal length positive, concave lens is the one with the focal length negative. See, convex lens is the one with the focal length plus f1 and concave lens is the one with focal length minus f2. So if both are in combination, 1 by f can be written as 1 by f1 minus 1 by f2. Right. So that here I want to take the reciprocal. So if you want to take the reciprocal, this LCM is f1 and f2. You will get f2 minus f1. I want to know what is f. F is equal to f1 f2 divided by f2 minus f1. This is the final formula required for the effective focal length of a combination of the one convex lens and another concave lens. So okay, we got this formula so that if we combine one convex and one concave lens, the effective focal length formula f is turns out to be equal to f1 f2 divided by f2 minus f1. Hope you know, suppose if we use only two convex lenses, then the combination of two convex lenses again acts as convex. Suppose if we use the two concave lenses, the combination of those two concave lenses acts as a concave lens. There is no any issues in that. Suppose if we use one convex and one concave, ಹಾಗಾದ್ರೆ ಅವೆರಡನ್ನೂ ಜೊತೆ ಕಂಬೈನ್ ಮಾಡಿದಾಗ ಅದರ ಎಫೆಕ್ಟಿವ್ ಅವೆರಡರ ಕಾಂಬಿನೇಷನ್ ಕಾನ್ಕೇವ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತಾ, ಅವೆರಡರ ಕಾಂಬಿನೇಷನ್ ಕಾನ್ವೆಕ್ಸ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತಾ ಅಥವಾ ಅದರ ಕಾಂಬಿನೇಷನ್ ಗ್ಲಾಸ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತಾ, that we should know. So now, let's just consider the cases. So for this I am considering a case 1. So in this case 1, if f1 is equal to f2, if f1 and f2 both are equal, then what happens? F is equal to f1 square divided by 0. It means f is infinity. Similarly, if case 2, if f1 is greater than f2, so you can observe that if f1 is greater, f1 is having a minus sign, so that the effective focal length becomes negative. Similarly, we have the last case, that is the third case. If f1 is less than f2, right, then focal length becomes equal to was obvious, becomes positive. Okay, we got the three cases. One is infinity, one is positive, another one is negative. My dear students, you should be very careful that if the effective focal length is infinity, then the combination of a convex and a concave lens acts as a glass plate. So it means even you combine one convex lens and even you combine one concave lens, then you will come to the conclusion that due to the focal length of both the lenses are same, that is going to act as glass plate. Then if f1 is greater than f2, that is what the focal length is negative, then we can say that it is going to act as a concave lens. It means the combination of convex and a concave lens acts as a convex lens, and then the combination of the concave and the convex lens acts as a convex lens when the total focal length becomes equal to positive. S becomes equal to positive. So these are all the formulas that what I just written it on the board. So suppose my dear students, even if you want to deduce the expression just by using the two concave lenses, what happens? So you know the formula, 1 by f is equal to 1 by f1 plus 1 by f2. So 1 by f is equal to, if I use two concave lenses, so that f1 is also minus, f2 also becomes minus. So it means we can come to the conclusion that so we have the negative of the sum of the two focal lenses. Why? Because here if I take minus as a common term, so here it will be the 1 by f1 plus 1 by f2. So this indicates that the effective focal length is equal to negative of the sum of the reciprocal of two individual focal lengths. This is about combining of lenses. So my dear students, hope you got how to combine the two thin lenses in contact. So combination may be convex-convex, combination may be convex-concave, combination may be concave and concave. So my dear students, with this, so I am just going to conclude this class. So hope you are all writing up your notes. So follow up each and every day class. So hope you are all reading and you are preparing well for your examination. Thank you.